Ooh. Hello, everybody. So my name is Olaf, and I'm really excited to be here and present Metals, a project that provides rich code editing for Scala and text editors such as VS Code, Vim, Emacs, and beyond. So briefly about myself, I'm an engineer at the Scala Center. Our office is on campus here, which makes this moment even more special to welcome everybody here. I'm the author of a code formatter called Scala FMT, a refactoring tool called ScalaFix, and Metals, the project that I'm presenting today. So you may have seen me as Ólafur PG on GitHub and Twitter. Before I get started, does anyone know here what the Scala Center does? Quite many hands, which is great. It's better than a few years ago. So we're a not-for-profit. We're established here at EPFL on campus. And our two primary focuses are on open source and education. So what I've been doing a lot at the center is working on tooling. And also, you may see on your badge, we're organizing Scala Days. And also, the work that I'm presenting here is really not just me. It's been a big collaborative effort with a lot of contributors. So I want to highlight Jorge, who's been working on Bloop. Gabriele, who's sitting here, came from Milano. And Marek and Tomasz, who are at Virtus Lab. And we've been working together full-time since April. So, and also want to mention a few other names: Eugene Bermacco, Alexei, Johan Mutsam, Shane. Before I want to go and talk about text editing, I want to talk about another topic that we talk a lot about at the Scala Days, at the Scala Center, which is how do we grow the Scala community? And I think everyone here who have flown all over the world to come and be present at Scala Days should also be thinking about this question. Is, we have a Scala community now in 2019, and let's say we want to double it in 2021. Very ambitious goal. How do we get there? And it's a really difficult problem, and there's no silver bullet. You're going to have a lot of different solutions. So my thesis for the talk today is that improved editor tooling is one component. And I'll tell you why. I think the first question when you onboard someone on your team, they've never written Scala, the first thing you think about is, what editor do I use? What IDE do I install? And if you Google online what IDE to use with Scala, you'll find forums on Reddit, Stack Overflow, Quora, people asking the same question. And it's been going on since 2005. And usually they're heatedly, commented. People like to have an opinion. I like this one here, who says, I'm a newbie with Scala. I'm developing a Play framework app. I've tried Scala IDE based on Eclipse and IntelliJ. In my opinion, the first one looks not mature yet, and IntelliJ seems better, but I find it a bit slow. I'm looking for the Sublime option, but it's not so documented. So I really like this comment because it highlights some of the points I wanted to make. It's someone starting with Scala, but has like a particular goal. I want to do a Play app. And this person has tried to use different IDEs, but is really looking for the Sublime option because I'm guessing that's what the person is familiar with. But if you've been long enough in the Scala community, you'll know that the most upvoted answer is definitely IntelliJ without any explanation. and that's also So the 2018 Scala Developer Survey kind of confirms that. 81% of the respondents said that they use IntelliJ. And this may not be surprising for the people here in the audience. Can I do a small survey here? Who uses IntelliJ for Scala? Yeah, that's about 80, if not 90%. So I want to take a moment here and look at that, the 81% number, because if you take the global programming community, it's not the same. So if you take the GitHub Octaverse, they claim that there are 31 million programmers globally in the world, and that's a fair estimation, I guess, GitHub users, number of developers. And the JetBrains developer survey from 2018 says that they have 6 million people who use JetBrains products, including IntelliJ. And that's a really impressive number, and JetBrains products are really fantastic. But that still leaves 25 million programmers out there who've never even downloaded or installed IntelliJ. And so if the 2018 Stack Overflow developer survey, you'll also see a similar pattern, which is that IntelliJ has 25% of the most popular, 25% of the respondents say that IntelliJ is their favorite development environment. And it's at the 6th place. There are 5 other editors, including Notepad, that are more popular. But also notable editors such as Vim, Sublime Text, and Visual Studio Code. So there is an editor gap here. Like the representation of how people use editors in the Scala community does not reflect how the global programming community uses editors. And I think this should be kind of a big concern, going back to the question, how do we grow the community? And it's partly because learning a new language is really hard. You need to learn syntax, you need to learn semantics, but learning a new language and a new editor with all of the shortcuts and key bindings and everything is even harder. And this pretty much reflects how I started in Scala. I started writing Scala in 2014, and I used Eclipse for quite a few months. And I chose that because I was familiar with Eclipse from Java, and Eclipse worked great. I learned Scala. I was able to actually do a play app, like the person on Reddit. And then eventually I switched to IntelliJ because, well, it provided a more feature-rich experience. But what's really interesting is I switched to IntelliJ. I didn't have to learn Scala. I was already familiar with it. So that out-of-the-box experience of using something that's familiar so you can learn Scala faster, I think is one of the key components if you want to grow the community. So a few years go on, and in 2019, I've actually started using full-time now VS Code with medals. And that's what I'm going to be presenting today. So now we can go back and talk about completions and errors and all of the stuff that this talk is really about. So a quick tour. Medals works with currently officially supports 5 editors, which means that that's what we document on our website. It works with VS Code, Vim, Emacs, Atom, and Sublime Text. So it works with any other language server compatible editor, but these are the ones that we have tested, validated, even add maybe some customizations to really improve the user experience in these editors. And if you're using since last week, or actually since the official release last night from Tomasz, we officially support all of these 4 build tools as well. Meaning that if you just open up Medals in a workspace that has any of these build tools, it'll do all of the installation automatically for you. You don't even have to go online to the website. It'll just click of a button, import this build, and it works. So, and then once you've installed it, it has a ton of functionality. So I'm not going to go through all of this list here. Instead, I'll just do a very brief demo just to give you a taste. So what I have here is the medals and VS Code open up in the Akka repository. And some of the first things you'll see is there's an outline view here. You can walk through and browse the classes. You can fold some code. And you have completions. And then we have some other fancy features like exhaustive matches. And so that's pretty cool. And then, let me show you. We also show if you hover over, you get a really nice information about the types. And I think this one is really helpful. We show 2 parts. One is the expression type, which is the type of that expression. And it's highlighted, but it's a bit difficult to see now. But we also show you the generic signature of the method that you're calling. Because I think both pieces of information are really helpful. And so if you hover over a method that has some docstrings, we'll also give you nicely formatted docstrings. I have water, thank you. And that works both for Java and for Scala. And yeah, you can go to definition, you can find references, and there I just clicked on and I found 530 references to a new symbol, and it was not at all cached. We try to be very fast with find references. So just briefly another kind of out-of-the-box experience, how it works. I have another installation of VS Code here that is has no extensions at all installed. I've opened up just a Scala file in a mil build, and what happens is that it pops up and says, I can help you with Scala file extensions. And there are quite a few. We don't have so many downloads yet, so we're not at the top yet. But if you install it, then everything should follow from there. If you go open up the Scala file, it takes a moment for the server to start. And oh yeah, I had already maybe imported the build here, so everything should just work now. Yeah, all right. But it would have prompted me to import the build, which is a mil build. So let me see here. So let's see that. Yeah, all right. Then that gave you a taste of how Metals looks like. Is that on? All right. So as you saw, there's a lot of features, over 15, 20 different features, and I'm not going to go and enumerate every one of them and show you how they work. Instead, I think it's more interesting to focus and go more in depth on two topics. So the first one that we struggled with, and that was the first feature that we had to implement, was diagnostics. And they are the red and the yellow warning squiggles that telling you that you have an error. And the challenge here is to get them fast and have them relevant, like they should be helping you. And then the second case study will be doing completions. So also giving them with low latency, but also support them in a large number of positions. So let's start with the errors. As you can see here, we're kind of shuffling between a file that doesn't parse and a file that has a type error. So the type error says number should be of type string, but it's actually an int. And when we insert the string interpolator, we're missing a closing curly brace. And essentially what this case study is about is to how we tackle this problem of trying to provide these errors so that they're helpful, but do it fast, in a fast way. So there are two approaches to actually do diagnostics, I would say. One of them is you can just publish them from whatever you compile. You run compile in your build tool, and then you scrape the logs and you put it into the editor, and that's what I would call publish errors from the build tool. And an alternative approach is that you have a presentation compiler, like a library API, where you do that compilation yourself in the IDE, and you publish them directly yourself. And the presentation compiler approach is pretty much the industry standard. It's used by IntelliJ, Scala IDE, TypeScript, Java language servers. So Metals uses the one from the build tool. So I'm going to explain why we do that and why I think it actually has really nice properties. So in a nutshell, when you type compile in SPT, it's going to run compiling 128 source files and then give you an error because you have some problem. And what Metals does is just take that error and shove it into your editor. And this has some very nice properties. It's essentially correct by construction. Whatever you have in your build, that environment is perfectly reflected in your editor. There's never the case where something like a dependency is off sync or anything, because it's the same thing. So if you're using, Ammonite scripts, which have a different build tool, well, we should get the errors directly from that source instead of trying to reproduce that environment. And another one which I think is really exciting as well is that because we perform that batch compilation so frequently, we can share it with your tests when you're running. So as you're editing, you're performing those CPU cycles that are needed for you to run tests anyways. So whenever you go from your editor into your terminal, you don't spend any moment compiling because it's already compiled. So I think these two key components make the published diagnostics from the build really appealing. And the first thing that you would expect, doesn't everyone do this? It sounds fantastic. Well, you get slow feedback. As you're editing, it may not be as interactive. And another downside as well is that you need to save the file because the contents that you're editing need to be visible to the build tool. So let's tackle one of those two, both of the downsides, slow feedback and requires file save. And we'll start with the slow feedback. So having looked at this a bit, and we were looking at how to speed things up, the first lesson that we learned was publishing errors is pretty fast. You essentially run that pipeline, and the errors come streaming from the build tool, and we can just put them straight into the editor. Or it's as fast as the build can be. But one of the challenges is that removing them, knowing that error is gone, can be a bit slow. So we're going to look specifically into that. How do we clear it? So imagine that we have 3 source files, A, B, and C, and A has an error before. You run the batch compiler, and it runs in phases. So it'll run the parser phase in all 3 files, and then it runs the typer phase, which is usually the expensive one. And then it runs 20 more phases, and then eventually we'll reach the JVM. And let's say everything succeeds perfectly. We know, hey, there are no more problems in this file. Then we can clear it. And that's kind of the naive approach. If you say, okay, let's clear the errors, you have to wait through all of these phases to finish for all of the files. And that's a bit difficult. So what you could do instead is to group the errors by the phases that they are published in, and then just publish it after the parser phase is finished, which gives you a bit faster feedback. But it gives you faster feedback, but again, you're still waiting for the typer phase to finish for all of the source files before you can clear. So essentially, instead, what you could do is you can group the errors by whatever phase and unit they appear from, and then you clear once those are finished. And this approach is implemented in Bloop, so this is not implemented in Metals, but it's one of the key components that really sped up that you fixed an error and it gets removed. And this was a huge improvement, I think, in the user experience, and it was really great. So Metals communicates with Bloop through the build server protocol. IntelliJ also has a client implementation, and you can plug in any other build tool that you want, which I think is really great because it's extensible. So if people are using Bazel or Pants, you could plug in another build tool. But also keep in mind that some of that custom work in terms of providing faster feedback will need to be implemented in those build tools as well. So that maybe gives you a feel of how Metals works. And one thing that we did was like a very cheap win in terms of giving you faster feedback was we only published that we can use like the presentation compiler approach for syntax errors. So you can run a parser. You don't need to know the class path. You don't need to know any of the dependencies or the build pipeline. And if there's a missing, closing parentheses or an unclosed string literal, we can just publish those right away. And as you can see, there is a type error below which was published from the build tool. The trick that Metals does is that it's able to work really well with an old snapshot of a file that has a type error, and then we get new syntax errors, and then we have to compute how they align into the new file. And once we get that working, you're able to get pretty snappy feedback as you're typing while keeping very stable type errors. So I think this also helps a lot with the slow feedback. So, I mean, I'm not going to claim it's a solved problem. It's probably still slower than what you'd used to. But for me personally, in the projects I'm working on, which are small to medium size, it's pretty good. And it has those really nice attributes of correct errors by construction and shared compilation with run and test. So let's look at the last piece, which is requires file save. So if you've just typed in this thing into your buffer, which is an invalid program, it specs a string, but it gets an int. It should be an error, but there is no error in the editor because you have to press save, and then you get an error. So if you're coming from an editor like Eclipse or from IntelliJ, this may be a bit counterintuitive. And what you can do is, let's say you fix that error, and the error is still there. Well, it's there because you haven't saved yet. So I've seen at least people like that out-of-the-box experience opening up Metals and like, oh, it's not what I expected it to be. Having worked with it now myself for a few months, I'm no longer sure if it's really a feature or a bug, because when you press save, it triggers that type checking, which is expensive. It throttles your CPU. And having control over exactly when that happens, because you're editing you're obviously editing an invalid program, otherwise you wouldn't be editing the program. So most of the time it's broken anyways, and most of the time you know what's broken. So I find the workflow where you can just type without being distracted by moving errors, by you're finishing something and saying, hey, this is a wrong identifier, is really nice, I think, in Metals, that you can just type it at your pace. Maybe you took a sip of coffee and nothing is going crazy now. And then you press save when you want to get the error. So I just recommend you give it a try. But I just took the liberty to flip the downside into an upside and say it's a feature. So, so that's the story around diagnostics. And there's more to it, but I think these were the ones that were kind of interesting and worth sharing. And the second one is a feature that I think everyone cared deeply about, completions. So I'd been working on Metals, I think, for 7 months, and I wasn't using it for my day-to-day development. I was still using IntelliJ because we were missing completions. But once we had completions, along with parameter hints, which are the ones that show you the parameters that you're filling in, and also being able to show the types, these all three came together in one release. I was able to switch, and I haven't really even had the urge to go back for a lot of reasons, but mostly because they're just really good and relevant, and they're really fast. So I'll explain how we do that. So we use a presentation compiler approach. So as I mentioned before, we use the build tool for the errors, but for the completions, we run our own presentation compiler. We need to know the class path, and we need to reproduce that compilation. But we have the liberty of not having to publish any errors. We can do whatever we like, because giving you completions, like false, like not giving you completions because there's an error is not the end of the world. So that approach works really great here. I remember before I started working on Metals, I heard everyone talk about the presentation compiler, and I was like, where do I depend on this library? And I didn't even know what the class was called or how do I use it, and there was no documentation, there was no website about it. So if you're curious, it's a class called Scala Tools NSC Interactive.global, which extends the Scala batch compiler. You can depend on it by depending on the Scala compiler artifact. And it's used by the REPL, Ammonite REPL, the Scala IDE, Scala Fiddle, a lot of other tools. And it implements essentially two kinds of completions. One of them is the scope completions, where you just pull out an identifier that's already imported in scope, and member completions, where you would do a dot and it will list out the members of that type. And as I said before, I've just been really pleasantly surprised that it's snappy and it provides just really reliable member completions and scope completions. But for that rich completion experience that I was used to in IntelliJ, scope completion and member completions are not enough. What I was missing was quite a few other completions. And that's what Metals implements on top of the presentation compiler. So I'm going to go through quite a few of the pieces that we do to kind of make that experience richer. And the first one highlights also that it's not that the presentation compiler should really even have these features, because these features require an editor, because you perform refactorings. We can explicitly move the cursor. There's all sorts of things that would be really difficult to encode in the library API of the presentation compiler. Essentially, it just gives you a list of symbols, and it's up to us to figure out what to do. So the first one is when you press enter and you select an item, you can say, this is the refactoring you should perform on the document. And one of the things that you can do is you can have snippets, which is essentially you say, it should insert opening parentheses and move the cursor inside of the parentheses. And when you finish that, you should trigger parameter hints. And that's what you see when you select iterator, which is a nullery method. It shouldn't have any parentheses. And you select filter, it moves the cursor into the filter parentheses. And when you select next, it knows that there are no arguments, so it moves the cursor at the end of it. So it's pretty basic, but it's still kind of an important piece of that day-to-day experience of writing code. So one of the fanciest features that we have is exhaustive match completions. If you do a match completion, it'll provide you to say just a regular match or an exhaustive match. And what we do is, this works for both sealed types as well as not sealed types, which is different if you're coming from IntelliJ. So if you have sealed type, sealed ADT, it works for both whatever you have in scope, but it'll also work even if those none and sun, even if they're not in the scope, we would auto-import them for you, which is what you would expect. But if it's not a sealed ADT, if it's just like an exception, we will, no, we don't exhaustively match all of the subtypes of exceptions. But yeah, I'm sorry, I forgot that we give you all of the exceptions when you do the case completions. So I'll just jump into the next one. So one thing that we do here, which is really nice as well, is that not only exhaustive matches, but individual case statements. And I think this is really a feature that I never had in IntelliJ, and I really enjoy Metals, is that you're doing a collect and you're just taking one of the cases. And this is the one that works with both sealed types and also for exceptions, because it would just provide you the completions of all of the exceptions that you have in scope. And I find this to be really useful. And another polish, it's just a small thing, but it's one of these things that required a bit of thinking, was that if you have case and you do and, we know that none matches the type of the qualifier of that match. So we'll sort it at the top, but we don't filter out the rest, because it might be that you want to do nil dot something else, or it's really that would be an expensive analysis. But just the sorting is customized and tweaked and polished. So the next one, which I was desperately missing, which was overriding methods, implementing something from an interface. And in Metals, you can do that one method at a time. You go into the body, like the template of that class. Here we're extending seek, which has like 500 methods, but only 3 of them are abstract. So when you do the iterator, you can see that the iterator is sorted at the top, because that's the one that we should implement first. But then we go back, and then it's all the concrete ones, and we automatically know that there should be an override keyword. And we also compute the correct kind of, it's a seek of int, so then it should be a filter with an int2 boolean. The next one, which is a very important feature as well, and it's really saving you a lot of keystrokes, is you say, oh, I need to access that API paths. And as you can observe, we insert an import at the top. So if you come from IntelliJ, you take this for granted. It just works perfectly. But this is not part of the presentation compiler, so we had to implement that ourselves. And the way we insert the imports is nowhere near as sophisticated as IntelliJ does it. We just take that symbol and we import it at the bottom of the global import list. So you will have to manually go up there and sort them according to the conventions of your project. It would be really nice to solve that down the road. But it's already really good as it is, better than nothing. So the next step is that you do, and I think this is a piece that I cared a lot about because I hit on it all the time, is that you have conflicting names. You have files already imported, but you want to use another API, which also has the name files, because library developers use the same names all over the place. And it's really frustrating if files would only show us the file that is in scope. Metals always does a full search on the whole thing. Every completion is exactly the same. We wouldn't filter out something. There aren't any smart completions that you have to do with another shortcut to get these results. It's just a single command, complete. We do the full search. So if you're going to do com Google I/O files, we know, well, hey, this is already a conflicting symbol in scope. We'll just fully qualify it for you. And I find this really nice. So another completion that we do, which from the kind of scope and member completion perspective makes no sense, is that you want to do a scope completion on the code as if it's written inside of a string literal. So this was kind of a cute thing. It didn't take a lot of work to implement, but you have to understand that you're inside of a string literal. You have to do your own parsing to figure out that's the identifier. You pull out the scope of that identifier, and then you figure that, and then you have to perform the refactoring to insert the the leading S, and also you have to escape some identif characters in the string, and sometimes you have to put the curly braces. And then once you have the args, you can also select a member, which was just done the same way. But I think this was one of my favorite features to implement. It was a lot of fun and very useful. So you've seen all of the features now, and there are more, but I think these were the ones that were most interesting. So a lot of customizations on the feature, adding more richness, but we also added a few customizations to try to squeeze out as much performance as we could, because it's latency sensitive. So as you're typing, you want to get the feedback as fast as possible. So these are, I would claim, the biggest contributors to having decent performance if you're going to do completion with the presentation compiler. And we'll go through each of them individually. So here's a benchmark doing, it's actually a 6,000 line file, but doing completions on a member where you do dot. And the first line is essentially, we just did a new presentation compiler and we just gave it the full class path from 0. And it does that completion with a hot JVM, so that was 90 milliseconds. So if you just keep around that compiler instance, and then you do another completion in a different file, then it will be 40 milliseconds. So you shave off 50 milliseconds just by reusing that compiler. So this seems like, you know, a no-brainer win. But you also have to be careful that the longer you use it, the more symbols get added to the symbol table, and it's likely that you may get more and more wrong results. So it's a kind of a delicate balance between trying to reset it and reusing it. What happens usually is that you get requests in bursts, like 5 completions in a row, all in the same source files, 2 parameter hints, 3 hovers, and then we reuse, but then Metals is very aggressive at resetting it again and again and again. But it really says that most of the requests were able to shave off those 50 millisecond overhead, which is significant. Another, I'd say, biggest contributor to it being also robust and performant is that, so in Scala you can have compiler plugins. In SPT it's by add compiler plugin. People have linters, wart remover, all sorts of stuff. Metals essentially has a whitelist with 2 approved compiler plugins. If you're using Kind Projector, we allow it. If you're using Better Monadic 4, we allow it. If you're using any other plugin, we disabled it. So if you have and it's from the observation that most compiler plugins actually don't change the semantics of the language. So these 2 actually introduce new, like if you wouldn't have Kind Projector, the completions would break. If you don't have Better Monadic 4, they would also break in weird ways, but less obvious ways. So we disable everything else, including Macro Paradise. So Macro Paradise also qualifies for the changes the language semantics, but it also transforms the trees that we get so much that all of the positions are broken. So the completions don't work anyways if we enable it. You may be wondering now, oh, I'm using macro annotations in my project. Does that mean it's totally broken? And that's not at all the case. And that's a really cool observation, is that if you have macro annotations in your project, the completions work totally fine with them. They only don't work if you have an annotation in a source file and you're trying to complete in the same source file for those members. So if you have another project or another separate file where they're expanded, they will appear in your completions. It's only if you're in the same file. But that was a pure trade-off because you miss a few completions in that case, but if we enable it, you'd miss almost all of them anyways because the trees are broken anyways. So that was kind of how we ended up. Another one that we do is we actually disable black box macros. We don't expand them. And this saves from some benchmarks in like a source file with 200 lines, very small one, doing some fast parse parsers. Was able to shave off around 130 milliseconds, if I remember correctly, by just turning them off. And if you're not familiar with black box macros, they're essentially some code where you write, let's say here, you want to generate the timestamp at the compilation time. So what happens is that the compiler will invoke this code, it will execute it at compile time, and then put in a new syntax tree based on what you expanded. And just observe here that it returns along the tree, but it's annotated as an any. I'll explain that in just a bit. But Blackbox macros have this really nice kind of attribute that you can disable them and they don't affect completions in any way. So the completions are totally accurate even if you discard them. You're just getting 150 milliseconds shave after your type checking, which is awesome. There's another flavor of macros that are called Whitebox, and there's no way if we disable them, we would produce incorrect results. And I'm just going to briefly explain why. So if you have the original code, which would be something like macros.timestamp, if it was a Blackbox macro, it gets expanded into that tree, but because the method has an any type description, the expansion engine will ascribe that expression to any. So it doesn't leak that it was a long. But a Whitebox will not do that type description, meaning that the X will have the type long, meaning that the type of X will influence the completions in the rest of the source file. So this means if you're using metals with a library like Shapelist that has HList generated by macros, you will get the correct HList from like a person with an HList of string and int and hnil. But just keep in mind that you're paying also for the cost here. Another big win is just by not doing handling requests at all. That's even better. You go down to 0. So imagine that we have a request queue. I've probably been moving my hands in the wrong direction the whole time because the screen here is wrong. But anyway, so the request queue goes this way. And we are responding to the first completion here. And in the meantime, while we're responding to it, the editor sends us 3 new completions. Once we're finished with the first completion, we cancel the 2 that are older and we start working on the latest completion. And this was only changed now in the last release that was coming last night, in the sense that previously we would respond to them in order, and what we could have is getting up like a really long queue of requests and you wouldn't get feedback. So now we just prioritize whatever you just submitted, and that makes sense in a world where you're editing and you only care about the last completion that you triggered, not the one that was before. And this is great because we shave off, we skip a bunch of requests. And what we can do as well is the editor can send us cancel this. So even while it's in progress, metals, if the editor tells us cancel this, we will be able to turn off and even stop the type checker during middle of type checking, thanks to the cancellation support in the compiler. So that's really great. And the last piece is a feature that is just implemented in the compiler, in the presentation compiler, where you can, instead of type checking the whole source file, you can give it a position and it will just type check down to that position. And you get the typed tree at that position. So here, just as an example, we're completing numbers. That means we need to go and type check the object metals. We get numbers, but it has a type description list of int. So we don't have to type check the one in the body of that method. So this works out of the box if you just use the presentation compiler for scope and member completions. But with all of the customizations and extensions that we do, we need to work a lot with the compiler trees, and they're half type checked. So if you're working on the code base, you'll come in, you need to be aware that it's really easy to have no types on some trees. And you need to be aware that you should use just targeted typing. And that's pretty much how Metals does now, and it makes a huge difference. I don't have any numbers, but for the parameter hints, it went from just like, oh, I don't want to do parameter hints because it was so slow, to the point where it was just always there and I didn't bother. So it made a huge difference. So as I've said before, Metals has a lot of features, and we've had covered 2 case studies of diagnostics and completions, but there's a lot more to it. So feel free to come to me and ask any questions if you're curious. I'm going to just very quickly go over the editors that we support, but it'll be a bit fast since I don't have so much time left. If you're wondering what's up with the hype around Visual Studio Code, I'll give it to you now in a minute. So it has really great support for other languages that are very widely used, primarily TypeScript and Python, like it's fantastic. So if you're using those languages coming to Scala, you probably want to just continue using VS Code. It has LSP support out of the box, which means that it's just built into the editor, and the VS Code team maintains that support, which is great. I don't think I'll have time to show you, but I wanted to show you, there are two features called Live Share and Remote Development, which are just fantastic. It allows you to pair program with a remote colleague, and you're just editing as if you're on the same computer in a Google Drive style collaboration. And it's fantastic. Remote development allows you to SSH into a remote machine. As in, you open VS Code and you just say, I want to open up a folder in an SSH remote. And then you're just editing on that machine, but you have the great UI with no fiddling with file watchers or anything. It just works out of the box, and it's fantastic. It has a great extension ecosystem, and having worked a bit on the Metals extension that we've written in TypeScript as well, I just enjoy writing the extension. It takes me you have good completion support, you press play, you get like a new fresh instance in 2 seconds that has that version of whatever you changed. So it's really snappy and great. And I've tried to do it with the other editors. It's just the best that I've seen in VS Code. And it's very actively developed. Like every month there are new releases, and I look forward to reading the release notes because it's just something exciting. So the only really bad thing I can say is that the syntax highlighting for Scala kind of sucks. It's gotten way better thanks to a contributor called Panayon for the past weeks. And I'm just so thankful to his work because previously it was especially bad around string interpolators and non-ASCII identifiers and stuff like that. So I'm actually just going to skip these because the time is out. But Live Share is really cool, so give it a try. And the remote development, where you can just, you can code on a machine with 100 cores and 200 gigs of RAM, and it just works seamlessly. There's no you just do it from the VS Code UI. It's fantastic. So give it a try. So for Vim, it's legendary model editing. I've used Vim myself for Python development for a while, and I loved it. It has, I'm just going to say, it wasn't the case a year ago, but today it has a comprehensive LSP support. In fact, there are two different plugins that comprehensively implement most of the spec, which is just fantastic. And I'd say the biggest complaint I can have, having tried to use it now with Metals, is that if you want to say, hey, would you like to import the build, that is a blocking UI widget. It would be really nice to just have a thing that's on non-blocking on the side, and you can continue editing and click on the button whenever you want. And this is really, really annoying. And if you haven't seen it, there's an in-development editor called Onivim, which kind of solves that problem, but still keeps all of the goodies of Vim. So I'm personally very excited about that one. Emacs, I don't know much about, so don't shoot me. But it seems to be legendarily customizable. And it also, not the case a year ago, but it has today comprehensive LSP support, which is just fantastic. And it supports pretty much all of the features that we support in Metals, including the advanced parts around completions. And I would say it's the same issue as Vim, but probably someone's going to say, no, that's not the case. You just need another plugin. But if you want to have a non-blocking UI widget to do imports, it's kind of invasive. And Sublime Text, I've never used really, but I have great respect for. It's primarily because it's legendarily lightweight, and it has really good defaults, in my opinion. And it's not as comprehensive today as Emacs and Vim, the LSP package, but it's actively developed, and I think there's an open PR adding some of the more advanced pieces and completions. So it's getting there really close, which makes me very optimistic, and I think is great. I would really wish Sublime Text, that sensible default philosophy, they should just have LSP out of the box, and it would be a huge boost for Sublime. And I just picked one thing. I'm sure there are other things, but we have commands like import build, and currently you have to copy paste JSON config. Every person has to do that. There's no way for us to, or maybe there is, but I haven't figured out. And lastly, Atom. It seems to be legendarily extensible. It has really these nice UI widgets, the same that VS Code has. But sorry, maybe someone is, I mean, the LSP support does not, the completions don't handle some of the more advanced refactorings that we do. I'm not aware of any current PRs fixing these issues. So like auto imports, like the imports just don't appear, which is really a bad out-of-the-box experience. So I would not recommend this if you're showing it to beginners and say just install Metals and use Atom. Like some stuff doesn't work, and there's no way for us to work around that. So that's it. So future work, as you can imagine, an IDE is a huge task. Running and testing and debugging, we have Marek, who is from Virtus Lab, has been working on this full-time now for over a month, I think, and I'm really excited and I'm optimistic we'll be able to have just run and maybe down the road even debugging, but also run tests, and you can see the past tests and the failed tests, and I'm really excited about that. Getting close to that out-of-the-box experience for a beginner who doesn't even have to know what Scala test is or something, and doesn't have to figure out the incantation for just testing a single unit test, because all of the testing libraries have different syntax. Renaming a symbol, we're pretty much there almost. We have find references. It requires a bit of more custom development to be correct. Refactoring support is non-existent at the time. LSP has great infrastructure for refactorings, but we just don't implement at the moment, and it's a big project. Worksheets, I think, would be fantastic to have if you could just open up a file and you can see the values in line, what they are, as you're just learning a new API. And I would estimate this is not that even hard to add with our current infrastructure. And the same thing, it's pretty much the same thing for SPT and Scala script files. So probably 100 other features that could be added. But these are the highlighting ones that I think are most exciting. Thank you. No time? Feel free to come to me if you have any questions. I'm out of time. Thank you. Just bees and bangs and